So my name's Seb Rose. This session's called Microservice Delivery Without the Pitfalls. Alan came and asked me right before the talk, do you need to know anything about microservices? And the answer is no, because microservices here is really a specialized term for software components. Even if you're not working with microservices, I'm pretty sure that you're dealing with more than one component at a time. So that's what the session's about. There's a whole bundle of contact details there. What I tend to do is ask people to ask questions just when they've, if a question comes up as we're going through the talk, just to ask it, stick your hand up, I'll try and notice. That I will attempt to leave time at the end for Q&A, but I'm not going to make any guarantees about that. But if a question comes up and you don't get a chance to ask me during the session, or maybe the question crops up in your mind, sometime in the dark hours of the night, then please feel free to get in touch with me on any of these channels at any time. And I do generally respond. I also add the caveat that I make this offer at every course I give, at every talk I give. It's a very cheap offer because very close to none of you will ever take me up on it. However, the offer remains, and I will honor that offer. So, without further ado, this is a talk that I've given a number of times over a number of years, and it's changed over the years because the environment has changed. And I've restructured it for today because it's a different audience, because it's a much longer session length than most conferences allocate. And it turns out there's quite a lot of things that I want to go through. However, please still interrupt and stop me if something doesn't make sense or you would like some clarification. Like all good talks, I'm going to start with an introduction. I'm going to end with some time for questions if I manage to budget my time, and there's stuff to go in the middle. So, the introduction. Let's just get the microservice stuff out of the way to start with. So, microservices is a term that's been around probably for just over a decade now. It's become, Sam Newman wrote a book about it. It's become very hip. It's become very hip. A lot of organizations have adopted microservice architecture, and in the same way they've adopted agile, because it promises flexibility, it promises speed, it promises cheapness, and it often delivers none of the above. But the idea behind microservice architecture is that you have lots of small components that are independently deployable, and therefore you should be able to swap them in and swap them out as long as they adhere to the same contractual behavior. You should be able to maintain them separately. That gives you loose coupling, which then gives you lots of organizational flexibility. Some of you may have read Team Topologies, another very hip book that came out a few years ago. And by having lots of loosely coupled components, it allows you to take advantage of maybe development teams in different parts of the world and outsourcing small parts of work, or maybe starting off by outsourcing that part of work and then creating a more specialized implementation for yourselves. And that means that you can really make the best use of the resources that you got, whether that we're talking about in-house resources or outsourcing. And because we've got small components, you have small teams. Because despite what a lot of the people in the agile world, the safe world and the dad world, etc., have been telling us, it's really hard to scale these flexible ways of working to big teams of 100 plus people. So there's a lot of benefit, or at least potential benefit, that derives from having small, loosely coupled components that make up your architecture. And so this is straight from the microservices.io website. The benefits are it enables a rapid, frequent, reliable delivery of large, complex applications and enables an organization to evolve its technology stack. These are all good things. I think you'll agree. These are the things that we're looking for. But this is not what we always get. So the challenges that people have when they work in a microservices architecture, we can characterize with some of these questions. I'm trying to develop this piece of code, but the microservice that I depend on isn't ready yet. So here we've got the idea of we're loosely coupled, but we're still tied in time. We're waiting for the thing that we depend on to be developed before we can work on the actual piece of code that we've been tasked to deliver. Then you may get microservices, but you don't have proper documentation. How does it work? What order am I supposed to call these things? How am I supposed to authenticate with it? What are the performance characteristics that I should expect? And possibly the most dangerous one is, I've got a new version of a microservice that I depend on has been delivered. I'm just not that confident that it works in exactly the same way. I'm going to tell a story about that in a wee while. But the consumer of the microservice isn't the only person who has challenges. The person who's providing a microservice also has some challenges. So we would like to be able to update our service. We find out new ways of doing things. We possibly have other customers who have made requests for changes in its behavior. But we don't know who's using our services as it is, and so we don't know who we're going to impact. We don't know who we're going to talk to about finding out whether this change is necessary or not. We've given up our service out there to the community to use, and we don't know who's been making use of which aspects of that microservice. Same goes for fixing a defect. So in fact, yesterday's keynote, Stephanie talked about Hiram's law, and this is a classic. We've got a microservice. We want to fix a defect. The first thing you'll find when you fix a defect in a service that's used by a large population of users is that somebody's depending on that defect. I had a conversation with someone from Microsoft a number of years ago who told me that there was a defect that he'd spent months working on, but when he got to fixing it, he discovered that one of Microsoft's very large customers had built a huge workflow that depended precisely on that defect. And so all that work had to be scrapped, and the defect was effectively enshrined in the contract. And the issue is, again, is that if you're going to work in a rapid deployment, rapid delivery space, you're going to have multiple versions being used by different customers at different times. Not everybody can update to the latest version as soon as you release it. And you really want to make sure that the compatibility between your version of a microservice and their version of their current consumer of that microservice is valid before you retire something completely. And so managing multiple test instances becomes an issue. You've got then lots of extra testing to do because you've got your latest version, but you still need to make sure that other things work with the older versions. And you'll find that at the end of each of my sections, I've got a so what, because you might be dozing. So if you hear so what, it's time to wake up again, and then you've got a thought. Yes?
Just proving your so what question.
Okay, thank you. So if you can't deploy, this is a quote from Beth Scurry. So Beth Scurry is a colleague of mine. She currently works for a company that I used to work for called SmartBear, but she works for SmartBear because SmartBear acquired the open source tool called Pact, which I will talk about later. And she's one of the original core developers and they're all based in Melbourne in Australia. And this quote I like very much indeed. She says, if you can't deploy services independently, you don't have microservices. You have a distributed monolith. And I'm not sure whether any of you have experienced this sort of distributed monolith, but it's when you have the sort of 3-month period at the end of a development cycle where everybody in the company contributes all of their bits of code, and you put it into a massive integration environment, and you crank through lots and lots of end-to-end tests and discover huge problems that you never thought that you would ever experience again. This is what we want to get away from with microservices, but if you cannot confidently deploy, or confidently and successfully deploy an independent microservice without changing all of the others, then essentially what you've got is coupling, deployment time coupling of your components. And this is what this is the thrust of this talk, trying to propose a system, or it's not even proposing a system, describe a system that exists to get around this problem. So this takes us to software contracts. And I guess let's ask, who thinks up here about software contracts? Is software contracts something that is important to you? Okay. And do you have a formal and systematic way of dealing with software contracts? And I think that's the problem, isn't it? We've got semi-formal, we've got semi-standard processes, but a lot of the time it just comes down to, well, we've got this sort of document, we check it, we think it's going to work. Oh, the compiler says it works, the linker says it works, but we better do some pretty hardcore testing to make sure that it actually does work. So I'm going to tell a story about Big Co. Big Co being IBM, but I guess I shouldn't say that. And I was working in Edinburgh on a port of a tool that they had acquired to use their new rational Jazz framework. And the Jazz team was in Raleigh, North Carolina, and we were in Edinburgh, so lots of hours difference. And we had to use the platform services that they were providing as a DLL. Not microservices here, right? This is absolutely not microservices. One monolithic component and a monolithic consumer of that component. And they were still working on it. So the Jazz platform does still exist, but it never quite delivered all the benefits that IBM were hoping for. And it was fine. When we had DLL version N and we managed to get our UI and our business logic working with it, everything was great. And then, they would ship DLL N+1 and all sorts of things that they weren't supposed to have touched in that evolution, that increment, then caused stuff at our end to break. Now, there were many failures in our project organization. We didn't have great documentation. There wasn't, the actual contract specification was in no way detailed. Even as a document, there was just nothing there, really. But we spent weeks of our development time trying to work out what the problem was. Have we misunderstood something? And we were debugging and going in and trying to trace through calls. And it was just a real pain. And so essentially we got to the point where every time they released a new version, we would internally and sometimes externally groan. Oh no, because we were going to have to go through this pain all over again. So we created a defensive test suite. So basically, we coded up a small record and playback tool where we would, with version N, we would go through a bundle of our key workflows, and we just record all of the traffic between our component and the DLL that we were depending on. And then every time they shipped another version, we would replay that traffic. We didn't have to use our code. We would just take the recorded traffic and chuck it at the new DLL and see whether we got the responses that we got the last time. Now, there's some issues there, right? So date and time is going to increment and change. Process IDs will change. There are areas that you don't want to compare exactly, so you have to do some masking on that comparison. But this was a really cheap way of just going, this is no longer working. And before we sort of screw up our integration environments and break our development workflow, we're going to pass it through this test gate. And if it fails at the test gate, then we go back and talk to them before we bring it into our environment, before we do any debugging at our end. So, as I said, the consequences are there are some data changes between the runs that you need to mask, but the failures, they weren't necessarily a signal that they'd done anything wrong or that we'd done anything wrong. It was that there'd been some misunderstanding between us and them. Maybe they'd misunderstood the scope of their changes. Maybe we had misunderstood what the extent of their commitments and their promises to us had been. We needed to talk to them. And that's a much cheaper way of having that conversation than having already spent hours trying to do debugging to work out whether you've made a problem. And our team became hugely more productive because actually they were shipping these DLLs on quite a regular basis for the time of, for the fact that it was 15 years ago. And the contracts between us and the DLL became much clearer. Still wasn't anywhere near formal, but we'll talk more about that as well. So And for quite a lot of this talk, I'm going to use some schematics. This is me introducing a simple schematic of today's everyday system. So think that we are, as a consumer, we're developing X. And most front ends or most significant business applications have multiple dependencies. And here I'm showing dependencies on other code built and deployed within the organization, maybe some cloud services. They might be maintained by us or maintained by other organizations or other teams, and of course, databases. And I'm 100% certain that this is a massive simplification. If you try to project your application domain onto this diagram, this would be a massive simplification of that deployment environment. However, this is still too complicated for the purposes of, pedagogy. So I'm going to, always forget that animation. So the each interaction between my component and the things that we depend on are governed by contracts. In the story that I told about the IBM Jazz issue, those contracts were not documented. They certainly weren't explicit. And nonetheless, here we see in this diagram, there are 3 contracts that this consumer called X needs to be aware of. But it's still too complicated a diagram for us to talk about today. So this is the model that I'm going to be talking about for most of the session today. We have one consumer, C, and one provider, P, and there is a nominal contract between those 2 components that needs to be adhered to by both sides. So what? Well, first off, this is not a new thing. Is anyone familiar with Bertrand Meyer and his work? A few hands there. So this goes back a long time. Is there anybody in the room who's actually programmed in Eiffel? So Bertrand Meyer was a very influential person, and he created a language called Eiffel, which nobody in the room has ever programmed in. I did try to work with it back in the late 90s, but it wouldn't run on the PC that I had, which, he was missing a contract there somewhere. Anyway, it's a great book because he goes into detail about, the Eiffel as a theoretical construct is really interesting because he talks about making the contracts explicit within the code. And he talked about design by contract. And what he said was that the contract has to be an agreement between he called them client supplier, and then now more commonly called consumers and providers. And the characteristics are that you expect some benefits. If there's a contract that both sides adhere to, you get some benefits, some certainty that things aren't going to change, that you can be relatively confident that new versions, if they adhere to the same contract, then your code that works against them will still continue working. But it incurs some obligations. You need to be a bit careful about what changes you make. You need to know who you might be impacting. You need to make sure that you work within the confines or the restrictions of the contract. So we're going to take a little break, a diversion, and think about traditional software testing at the moment. I'm assuming that all of you in the room test your software. There's a few shaking heads there. So, and I'm introducing, again, I'm afraid I'm introducing some terminology that, although it's fairly straightforward, makes sense, it's not necessarily the standard terminology used in the industry. So here, we're looking at a collaboration test. And this is a test that is trying to ensure that the collaboration between the consumer and the provider behaves as expected. And then once that test passes, and you go through various quality gates, eventually your component gets promoted into production, and there in production, you expect your consumer to continue working as you expect with the provider. So this is a test pre-production. This is the behavior in production. The collaboration test is also known as an integration test. So the reason I often change the names of tests, the categorization of tests, is because, the classic unit integration end-to-end, it depends what perspective you've got, whether it's a unit test or an integration test. Every unit test is an integration test at some level, and every integration test, if you squint hard enough, can be seen as a unit test of some subset. So that's that. But because it's a new term, I just thought I'd plug it in there. This is essentially an integration test. And here we have the contracts that we're trying to ensure are being adhered to. And if they're not adhered to, then we want to know why. Now that's an integration test, and the trouble with integration tests is that they can be quite slow and quite burdensome, because the things that you're integrating with, you need to have them running in a deployment environment. They maybe need to be have dependencies themselves. So, and if you don't want to have that transitive dependency graph, then you have to stub them out for the components you're integrating with. So typically, what we try and do is we try and replace, at least in early stages of testing, we try and replace that dependency on the actual provider of our service with a test double of some sort, so that we can do our testing in isolation. And in this case, it's still a collaboration test, but it's also known as a unit test, right? So this is the flavor that we're at. So if you're running an integration test, then your component is talking to something real on the outside. And if you're running a unit test, well, your component is talking to something that purports to replicate that external component. And this is typically how the world works. So developers will stub or mock out the dependencies, and then they will write tests to ensure that the component, the unit that they are working on, behaves as expected when the component, the external component, or at least the replicant of the external component, behaves as they think it ought to. And here we've got the developer both writing the consumer, but also positing what the provider or how the provider is supposed to work. And in both cases, we still have contracts. This is one of my favorite films. It's Dr. Strangelove. They are building a fail-safe device to ensure world peace. And it ends up not quite guaranteeing world peace. It ends up with total world destruction. What could possibly go wrong with this idea of taking your slow integration tests and replacing the provider that you're integrating against with a test double that behaves in the same way?
In your diagram, there's an implicit contract between the test double and the real provider.
Yeah.
Is that one of the...
Yeah, I mean, basically, there's an implicit contract, and the test double will implement the developer's understanding of that contract rather than the actual contract implemented by the provider. And that's why integration tests, to some extent, are more reliable. So when it works fine, everybody's happy, okay? We've done cheap testing during development against the test double, and then the test has passed, it's gone green, so we promote it into production, and everything carries on working green. And that happens sometimes, but not always. The collaboration test is making assumptions about this contract. And the test double has to satisfy those assumptions. However, sometimes, even when the collaboration test that makes assumptions about that contract passes, when we put it into production, or indeed maybe just a sufficiently production-like environment, we see failures. And that's because, or at least that might be because, there's different behaviors between the test double that you have implemented in development to speed up testing and the actual behavior of the component in production. So far, so simple. So what? Test doubles enable isolated testing of components. This is good because we want to test things in isolation, because if we can't test them in isolation, it becomes hard to test them effectively, but also it becomes really hard to test edge cases. So if you want to simulate timeouts, if you want to simulate network partitions, if you want to simulate people people doing silly things with data, then it's very hard to do that if you have to then configure all of the external dependencies to reach that situation. But test doubles don't necessarily behave in the same way as the components they replace because, well, you're only as good as the person who understands the contract and then tries to implement the test double. And that then leads to the place where when you test with test doubles, you go, it works on my machine. You've heard that. It worked in test. It worked in CI because it was running against the test double. And that gives you confidence to go, well, let's promote it into the next environment. And it just keeps getting promoted until finally discover that there's some discrepancy and you get the failure. And so based on, I just added this overlay after listening to Gail's keynote. Test doubles are only a model. They're a model of behavior. If they were the same, if they behaved the same way as the component they were doubling for, they would be the component they were doubling for. So we need to make sure that the model is sufficiently good to give us confidence that we can deploy our code, but we don't want to make the model exactly the same as the provider because, well, then we're back to integration test land. So, taxonomy. I don't know whether people like taxonomies. I quite like taxonomies. This is a very partial taxonomy, but I think it's useful to go, and it goes through some of the things, you mentioned implicit a while ago. So I'm using an analogy of a nut and a bolt. There is an explicit contract between that nut and that bolt. What elements are there in that explicit contract? Some of you may have used nuts and bolts before. You've certainly used screws. You are using nuts and bolts every day. So what's the explicit contract between a nut and a bolt?
The bolt width, the thread spacing, and the way that it twists.
There you go. So it's the bolt width, so the diameter here, the thread pitch, because you can have the thread pitched at different spacing, and also you get left hand and right hand turning. So that was, if I had Smarties to give out, I'd be giving out Smarties because that's a perfect answer. Is there anything else, though? This is the explicit contract between that nut and that bolt. Can you imagine any implicit elements to a contract between a nut and a bolt?
Interaction between the materials.
Interaction between the materials, that's a good one. Yeah, I hadn't thought of that. Thank you.
Strength of the materials.
Strength of materials as well, yeah.
Temperature, it can cope with.
Yeah. So these are all good ones. I'm afraid I'm going to go even more simple, because you're going to into the physical aspects. How are you going to use that bolt? So if you've got a nut and a bolt and and it's in an enclosed space, the shaft of the bolt has got to fit into that exposed space. Otherwise, you're never going to be able to tighten up that nut to make sure these two components are tight together. Also, some bolts come with shanks. And at that point, that's an implicit contract too. And it would be really easy, as we demonstrated, in this trivial Q&A. It's really easy to overlook some use cases of a provider and the desires of the consumer. So the first element of the taxonomy that I want to introduce us to is the fact that there are explicit contracts, and in almost all cases, there will be implicit elements to the contract that are not included in the explicit contract. If I think about, let's say, code, let's imagine that the method signature is an explicit contract, but in many languages, the exceptions that might be thrown by that method are part of an implicit contract. Java had an experiment trying to make it explicit a number of years ago. It's still, the vestiges of it are still there, but it wasn't universally welcomed, shall we say. So there's a spectrum of contracts. And I haven't introduced all of these these concepts, and in fact, many of them I won't touch on again. But on one end, there's something that is entirely implicit. There's nothing documented. Maybe you've just got an endpoint URL, and you know that you can chuck a get method at it, but you've no idea what payload you have to send to that get method to actually get it to respond properly. And at the other end, you've got things like EIFEL I mentioned earlier, where the contract is included in the code, and it's pretty formal, and Z, which is trying to actually, with a mathematical language, which is trying to make it entirely formal. And in between, we have all sorts of things that that try to make life easier to some extent for developers. I've talked about method signatures, which in strongly typed languages allow you to do, have the compiler check things. Later on in this session, we're going to be talking about Pact, which is a consumer-driven contract testing framework. And we have got Open API Spec, RPC, et cetera, et cetera. This is in no way meant to be exhaustive. Another way of looking at the categorization is that it goes from informal through to formal. So informal or absent is entirely implicit. Unilateral, and I will explain that in a minute, which is sort of the standard contracts that you get from ISO, et cetera. These are somebody provides a contract and then gives it to you and you've got to use it. That's partially explicit because they're trying to tell you exactly what's going on. Consumer-driven contracts, which is what Pact was created to support, are partially explicit. And then the formal style of contracts with Z and potentially EIFEL are explicit. We are going to cover basically these two in the middle. So I'm not going to bother with ones where there's no information at all, and I'm not going to go into the land of formal methods. So what? All interaction is governed by contracts, whether you can see them or not. It's governed by contracts. And they may be explicit, implicit, or more likely, a combination of the two. So we have these contracts, and before going into the explicit, implicit contract detail that Pact covers, I want to think about how we would actually implement a contract test. Or, in fact, what is a contract test anyway? So a contract test is essentially some sort of behavior that you run both against the test double and against the provider, and then you compare the results to make sure that they are sufficiently identical. So this goes back to my story about BigCo. We were actually doing it slightly different at BigCo, but it's essentially what we were doing. We were running the same feedback loop against both the component and the double to make sure that what we were getting was behaving in the way that we wanted. I first heard about contract tests in this format, or at least formally explained to me by a guy called J.B. Rainsberger, who was writing on the growing object-oriented software mailing list back in 2012. And he basically said that collaboration tests make assumptions about the contract, but contract tests try to justify those assumptions. So those arrows there are going to be, the contract test is going to be emitting exactly the same calls to both the test double and the provider, and then it's going to compare the return to make sure that they're the same, sufficiently the same. And so they're both making the same assumptions, and they're going to try and the contract test is going to try and justify those assumptions by comparing the results of those calls. When it comes to actually hand-rolling contract tests, and I've done this, and I don't recommend it, so we're going to move beyond hand-rolled contract tests. But I just want to start from first principles so that we understand what we're trying to achieve. We try and ensure that those contract tests work through an interface. So essentially, we have the test double and the provider sitting behind the same interface. So it might be thought of as a facade, but nonetheless, it gives you a uniform abstraction through which to do the communication. And here again, I'm going to rest on the shoulders of giants. Joe Walnes, many years ago, said, "Don't mock what you don't own," because it becomes very dangerous. The truth is that most libraries that we get to use are massive, and the amount of the library surface that we actually use is quite narrow. So let's define how narrow that interface is and make sure that we know which aspects of the library we are interested in testing, rather than mocking the whole thing. So we have our contract tests running through the interface, sometimes going to the test double, sometimes going to the provider and comparing the results. The explicit contract here in sort of Nordy C# is basically going, we've got an interface, revenue provider, and a method called getRevenue, which takes a customer ID and returns a decimal. What is the explicit nature of this contract?
Signature.
It's the signature. That's all we know. There's a customer ID that's an int going in, and we will get a decimal coming out. What implicit elements can you guess? I mean, I'm not showing you an implementation, so we'll never know, but just brainstorm it. What implicit nature elements of the contract might we want to consider?
Was that a valid customer ID?
Valid customer ID, sorry? Does it have to be a positive integer? The whole semantics, exactly. What might it throw exceptions? How long might it take? Do we always get a positive decimal out? Might we get a negative decimal out? Is it actually going to be? Yeah. There's so many things there. So the compiler can tell us that we're complying with the explicit elements, but our tests have got to know what the implicit stuff is. Otherwise, when the implementation comes back and maybe returns a specific negative decimal number, in error cases, that we should check it. That crazy things like that have happened. So are we going to pass in a valid customer ID and return a decimal value? But can we say anything about the magnitude of the return value? What happens with a invalid customer ID? And many, many more. So then we want to document the contract. And documenting the contract is through the contract test. So what we've got here, and I'm afraid there's a little bit of code here, but there's not much very interesting, I guess. We've got the revenue provider contract, and it has a reference to the interface to the revenue provider, which might either be implemented with the test double or implemented with the actual provider. And this is where we get the implementation. And in setup, we set up our revenue provider, and then the test, well, we pass in a valid ID to the revenue provider, and then we pass in an invalid ID. And in this case, we're documenting the contract is that we're expecting when an invalid ID is sent in, we expect a customer ID exception to be thrown. This is documentation of a sort. It's not immediately readable, and it takes a lot of boilerplate code and hand rolling to keep this contract working. So what? Contract tests run the same test code against production component and the test double. But doing this by hand is really onerous. It's just more code to maintain. So let's talk about documenting the contract in a less onerous way. When we're talking about the taxonomy, I introduced the term unilateral contract. This is also sometimes called a provider contract. And there are a bundle of organizations that provide these unilateral contracts. Sometimes they're done by a single organization, but more frequently they're done by collaborations, committees. C++ has the working group, is it WG21 that produces the next spec for the next C++. So unilateral contracts come from a sort of heavyweight, centralized organization that then publishes the agreed contract to the rest of the world. And they have a few properties. Unilateral contracts are generally closed and complete. Now, that doesn't mean they don't evolve, but as they are issued, they are final. There may be elements of the contract where it says behavior is unspecified if you do this, but in general, what you're given is what you get, and you either take it or you leave it. They're singular and authoritative, and they have bounded stability and immutability. So these are all good things in a lot of respects. But it does mean that you, as the consumer, really are the consumer, and there's very little you can do if something's broken or you don't like what you're being given. And so how you agree a unilateral contract is, optionally, you read the terms and conditions. I don't know how many people ever read the terms and conditions that you have to scroll through. Oh, well, one person, well done. You're in the minority. And then you click agree. More, packed, however, and a more, certainly more flexible, I was going to say modern, I'm not sure that's true, more flexible way of working is with consumer-driven contracts. Consumer-driven contracts, they are open and incomplete. The consumer says what they expect the provider to provide. Each consumer may have a different view of what they want this provider to provide. So when I was mentioning the fact that you should mock an interface, you should create an interface over any external components that you're using to specify only those parts of the library that you actually want to use. This is what different consumers will use different parts of the library, so they will contribute different elements or different parts of the contract. They still have some bounded stability and immutability. They're valid for a particular length of time. I'm aware there's a lot of text on the screen. The slides are available later if you would like to read them. But if you've got a consumer-driven contract, as in you as the consumer want to agree with the provider what services they should provide, how do you actually go about agreeing it? You might be a really small team, and the consumer and the provider are in the same team. You might be co-located in the same room. You might just be in the same team and on the same Slack channel or having stand-up meetings on a daily basis. That's less common today. Quite often you're in a bank or an insurance company, and certainly historically you might be in a large open plan office, and the consumer team's on one side, the provider team's on the other. If you've got a question, you can go up and ask your colleagues, or maybe you can book a meeting room if there's one available, and you can actually draw things on a whiteboard. You might be on different floors. At this point, you might even be in different time zones, right? So I don't know how many of you have worked in these office blocks that have multiple floors, but being on a different floor is like being on a different planet. Sometimes you don't even know where the toilet is on the other floor. But more typically today, we're all over the place, right? We have consumers everywhere in the world, and even the providers might be separated and distributed all over the world. So agreeing a consumer-driven contract needs to have some sort of structure around it. At least when you've got a unilateral contract, the committee will have a mailing list. There will be a limited number of people on the mailing list. They will go to ski resorts or Hawaii on a regular basis to drink mojitos and talk about interesting contractual elements and then publish it. But if you want to actually have a flexible consumer-driven contract, you have to have some sort of structure around it. Because you need to negotiate and document what that contract is. So consumer-driven contracts. Each consumer captures their expectations. So as I've said, we all have different needs from the providers. Some of them may be very similar, but in others may be very, very different. And so we have separate partial contracts provided by each consumer that is going to consume that provider's services. Those expectations have to be shared with the provider. The provider may say, when you pass to the provider an expectation, I expected to do this, they may go, that is not what we are going to do. So this is not the consumer dictating what the provider is going to do. This is the consumer going, from what I've understood so far, this is what I think you're going to provide to me, and I'm telling you about this in a formal way, and then we can negotiate. Thank you. All of these contracts are shared with the provider so they gain the insight of the obligations they must fulfill for each individual client. The provider then can create a test suite to validate these obligations. So the point here is that we have a communication protocol. The consumer thinks about what they want out of the provider. They document it and pass it on in a formal, agreed format. The provider will take those specifications, those contracts, and then validate them or compare them to their implementation or their implementation plan. And they can then say, that's a good idea, I hadn't thought about it. That's a bad idea, I'm not going to do it. And they know which consumer has contributed each of those partial contracts, and that opens a channel for dialogue. So what? You either accept what you're given or you negotiate. Neither of them are perfect. Consumer-driven contracts are really good if you've got a large organization and you need to communicate widely within it. The automation that we'll see in the next section, I think it's the next section, eases the communication burden, i.e. it doesn't ease the need for communication or remove the need for communication, but it makes it more obvious when communication is necessary. So I guess let's go a little bit deeper into consumer-driven contracts working well within globally distributed organizations. Consumer-driven contracts work well in organizations that are in the same country, in the same office, in the same place. So it's actually not just for globally distributed organizations. The benefit for using it in large organizations is that you will be able to, there will be very few restrictions from passing your expectations to the provider. Consumer-driven contracts are less beneficial if one organization is providing the service and then it's multiple other organizations that are not related that are trying to consume that service. Because then you have the question about IP and am I really going to notify this provider about all the things that I want to do with their service? Because that might be giving tricks away. So I guess maybe a better way I should phrase that is that consumer-driven contracts work really well within an organization, whatever its size. They work less well when you're talking about a publicly available service and the consumers are multiple and distributed and varied. So finally, microservices. Just a quick show of hands. How many people are working with microservices? Okay, thank you. As I said at the beginning, I simplified the application topography to one client and one provider. I'm now simplifying a continuous integration pipeline. So here I'm modeling it with just 3 stages in the pipeline. CI, so this is where you check your code into your source control repository, and typically the initial build happens and unit tests are run, yada yada. Staging, you may have some test doubles, you may have some level of integration tests with components that you feel are critical, and then in production, there are no test doubles, everything is a live production component. And what happens is that the component gets checked into CI, and either automatically on passing all of the tests, it gets promoted into staging, or maybe there's a manual check. And the same goes when a new version hits staging, a set of tests will be run here, and if that passes, either manually or automatically, it will get promoted into production, at which point your consumers will be deriving value from it, or be angry and frustrated because everything is broken. So this is a simplified pipeline because your pipelines may have dozens of stages in them, but for purposes of this exercise, 3 stages is enough to demonstrate the issues. We're talking about a consumer and a provider. And they both have independent pipelines because remember, in microservices, the intention is that each component, each microservice, should be independently deployable. Now, what I'm showing here in this diagram at the moment is that version 1 of consumer and provider is in production, and version 3 of consumer and provider is in CI. But obviously, if we can deploy each one independently, they aren't going to be necessarily promoted through the environments in lockstep like this. So what sort of testing should we do in CI to give us confidence that we can promote this component to the next stage? Is it sufficient just to test it with the unit tests? Probably not. Because remember, you need to make sure that you can deploy and promote them separately. Otherwise, you have to do it in lockstep. And if you have to do it in lockstep, it's a monolith. So, we obviously need to make sure that the component that we have in a particular environment is going to be compatible with the consumer that we have in a particular environment is going to be compatible with the provider that we also have in that environment. That seems straightforward. But if you're going to promote the consumer independently, you also need to make sure that it's compatible with the provider that's in the environment that you're going to be promoting to. And
You need to test C3 with P3.
say that, okay, yeah, possibly, yeah, that might be. Depends how much test doubling you've done there, but yeah, I accept that. And you also need to be able to promote the provider independently. And so you need to test the provider with the consumer in the environment that you're promoting into. Now, we've only got one consumer and one provider here. But you have more than two microservices in a typical deployment of microservices. So imagine this matrix, even with the optimization that you correctly pointed out, imagine this test matrix growing as you have multiple, many microservices, each of which will probably depend on more than one other microservices in the organization and will probably itself be a provider of services to other consumers in your microservice space. Quite quickly, you end up with loads of tests that you might reasonably want to run before you promote, before you have confidence to promote your component into the next environment. And that's without even considering the fact that you might have multiple versions of each component in a particular environment. So what? I'm going to start with, I've repeated this 3 times now. Obviously, I think it's very important, and I'm not alone. Microservices must be independently deployable. There are many environments in the deployment pipeline, but many microservices leads to the need for many compatibility tests between components in those many environments. And that was the matrix that was the beginning of the matrix that I was trying to show in that schematic. So, I've already told you that I think that hand-rolling contract tests is onerous. I mean, it is, and very few people ever did that. And I've now demonstrated that we have to run those contract tests, or at least we have to ensure that they apply and are valid for many permutations of component versions in environments. We're not going to be doing that in any enterprise application by hand. It needs to have some automated assistance. And I'm going to introduce you to one open source tool, Pact and Pact Broker, which was designed expressly with this in mind. There's the words. Pact provides a mechanism for creating a contract between a service consumer and a service provider, and then providing the tools to validate that the consumer and provider adhere to the contract independently of each other. So packed and packed broker are acting as a way of generating a contract and then in a decoupled fashion ensuring that the two sides of the contract adhere to it. This is the basic packed workflow. The packed website, I thought I'd stuck a link on here. Yeah, I did, packed.io down there. So packed.io has got some really good documentation. They've got some excellent videos. They have sample projects. I've leaned heavily on their resources when creating this slide deck. So the way it works is that the consumer developer writes some unit tests. Those unit tests will create a test double. And I will show it to you in a minute, but essentially, Pact provides a domain-specific language, a DSL, that you use when you're writing your unit tests that creates the test double. You then run the unit tests in the build, so this is the CI stage of the pipeline probably, and that generates this partial contract. That partial contract, and I will show you a very simple example of it in a minute, is a JSON or a YAML file that documents the interactions, what data was passed and what data was returned. That is the contract, or at least the partial contract. This then gets sent to the provider team, where it is replayed. So now instead of recording the results from the test double and writing them into the contract, what happens is Pact will essentially read through the requests, call the provider with those requests, and then compare the data returned by the provider with the data that's recorded in the contract file that was passed over. And there are also, of course, other tests that the provider team will want to do. So these consumer-driven contract tests are only part of the provider testing capability. This is a list of this is a sort of description of the DSL that's provided in the C++ binding for Pact. So Pact has got, and I think I list them on the next page, Pact has got a lot of different bindings. It was originally created for Ruby. There are bindings, DSL bindings now for most of the major languages. And as you'll see, that even if you don't find a binding for the language that you happen to use, you can create your own workaround. So the other thing I think that's quite obvious here is that this DSL focuses on HTML web type interactions. There's also a DSL, and I'm not sure if it exists in C++, but there are DSLs in some languages for working with event messaging systems. But it's quite simple. So I say it's quite simple. So that's a terrible thing to say, but it's a fluent language. So you go provider given upon receiving something with the request get to the URL/projects with a query, which you fill out the query. So it's supposed to be easy to read. It's a documentation DSL that happens to generate requests that then lead to responses that can be recorded. There's a couple of things, I guess, that I can point out here. That's not what I meant to do. See at the top it says, given I have a list of projects. This is specifying a provider state. I'm going to talk a little bit more about that later because that's one of the major complications of using this approach. But there's a DSL for working with HTTP requests, and you may be also able to use the DSL for using messaging systems. And this is what it looks like in a sample C++ project using Google Test. So I'm not going to go through and explain it all, but you see here we have a provider, and we've got given I have a project, and it's got some extra data there. Upon receiving a request to store an image, with this request happening, we expect the multi-part file upload to respond with a 201. So it's a declarative, fluent interface for essentially saying, this is the behavior I expect, and that's all the developer has to do. So it's a quite simple structure. And when you run this Google test, what Pact does is it spins up a mock HTTP server. So you're actually making HTTP requests, and it takes this initial given data to set up its provider state. So this is the starting state that we want to work from. It then sends the request, and it generates a response. And the response is actually, here it's a 201, but it might have a payload as well. And then Pact will generate the Pact file that captures both the request and the response. So Pact DSLs are available for, there you go, a whole list of things. And there are also examples of how to create adapters that will take the output from your favorite test framework and mocking framework and convert it into Pact format. So even if you've got an existing system that is using, I don't know, a WireMock or something like that, you can take the WireMock output and post-process it into a Pact format, and now you can work within a Pact ecosystem as well. This is a snippet out of a Pact file. It's just JSON that talks about, the description, the provider state, the request that was issued, and the response that was received. And again, it can have payloads in it that has more data. And this is essentially the target. If you're going to write your own adapter, this is the sort of format that the output of your adapter will be targeting. So what are the key points? It's the consumer that creates the contracts using Pact DSL. And of course, the Pact DSL is a programming construct. It's written into the unit tests. So by implication, it's the developer that's creating the contract, the consumer developer. When the consumer tests run, Pact creates a mock HTTP server and captures both the requests and the responses, and it puts it into the Pact file, by default a JSON file. The provider, then you pass the Pact file to the provider team, and they will then use Pact to essentially reanimate the Pact file and send these requests directly to the provider component that they are building, and they will compare the results to make sure that the expectations of the consumer comply with the implementation of the provider, and if not, issue an error, which means we have to talk to each other. And that little bit at the bottom about the provider state, there's the example that we showed there. The consumer provided the data to give the provider something to initialize with, but equally you can have named provider states, which could be empty, production-like, and so it gives the provider the ability to start up in a known state that is well documented. So in the middle of that description that I just gave, I talked about the consumer handing the Pact file to the provider. Well, that'd be a tedious manual process, especially if you've got dozens of consumers all around the world. So here's a simplified workflow. The consumer CI, when the build passes and the Pact file is generated, it then connects to a centralized Pact broker, which is in itself a service. The Pact broker, the provider CI, then pulls down that Pact from the Pact broker and compares it or verifies it against the provider implementation. This is all very simple. Again, it looks like, well, when does the publish happen? When does the fetch happen? So a slightly more complicated diagram, or slightly more accurate diagram, is that the consumer CI publishes the contract when the build succeeds. The Pact broker notices that the contract has been published, And then you can set up a webhook so it notifies the provider CI that there's a new pact that needs to be validated. That leads to the kicking off a build. The provider CI pulls down that pact file, verifies it, and then publishes the results back to the pact broker, which gets recorded. It then notifies the consumer, so the consumer automatically gets told, or can automatically be told, whether their pact files have been validated and verified correctly. And at both times, you might want to do an automated or manual deploy when it all succeeds. Of course, quite often, the contract hasn't changed. You might have changed something else in your build. So Pact Broker is clever enough not to send a webhook if the pact files haven't changed. Let's think about the more complicated situation where you've got many components in your environment, in your ecosystem. So this is still quite simple. There's only 5 here. But it's certainly more complicated than just 2. And we've got lots of different version numbers. So clearly, Z has been around for a long time. We're at version 72 over here, and we're working on version 84 in development at the moment. So what we want to do is we want to make sure that we can promote independently at any time once things are compatible. And there's some nice, it becomes very obvious. Maybe it's already obvious to you, but it wasn't obvious to me when it was first described to me. But it becomes very obvious that, in fact, when you run the CI tests when you run the tests in the CI stage and report it to Pact Broker can record the result of the pairwise result of the verification and say that version 32 of V32 and W3 were compatible with each other. And now if you ever want to promote V32 into an environment that's got W3, you can just look up that result and you know that these 2 components are compatible. So you don't have to run the tests every time you think about promoting. You just need to look up the version that you were looking to promote and against the version of all the components that it's dependent on in the environment that you're targeting, and vice versa, all of the components in the environment that you're targeting that are dependent on the component that you wish to promote. And Pact Broker uses something called a matrix. So it maintains a matrix for each consumer and provider. So there will be one table for each consumer and provider. So I haven't labeled it here, so this is just C and P, but you'd have one for W and X, one for W and V, in fact, one for every dependency relationship between a consumer and a provider. And it has, essentially, it's got a 3-column table. It's obviously not quite a 3-column table, it's more complicated than that, but it contains the consumer version, the provider version, and did it pass or fail? Now here I'm showing integers just for ease of use. More typically, these versions are GitHub shards or Git shards or something like that. And this then means that when you're thinking about trying to check whether you can promote a component into a particular environment, what you need to know is what versions of all the other components are already in that environment, and has this component that I'm asking about been tested against all of them? And if not, then it's dangerous. And if it has been tested against all of them, have they all succeeded? If not, then it's dangerous. So that's a really quick lookup, right? Even if you've got 100 components that it's dependent or depends on it, looking up 100 rows out of a table based on a pairwise comparison from the matrix, which is a database, is a very, very quick operation at levels of microseconds, milliseconds. And in fact, they have provided a command line tool called Can I Deploy? Can I Deploy? You say which component you are trying to promote, what version it is, and which environment you're targeting. And in fact, Pact Broker has an API which you will call as part of your pipeline when you deploy into each of those environments. And therefore, it will keep a track of which component has been deployed into which environments. So you have full infrastructure. You have the DSL to generate the packed files, and the packed files are created by spinning up a mock HTTP server or a mock event bus. You've got packed able to rehydrate those packed files at the provider side and make the calls to the actual provider implementation, and then compare the results to the expected results and record a success or failure to the pack broker. When you deploy, when you're happy that those results are satisfactory and you deploy or promote a component from one environment to another, you call an API on the pack broker to say, I have deployed this version of this component into this environment. And then when you want to actually check whether it's safe to deploy a component into the environment, you call can I deploy, stating which component and which version of that component you want to deploy into which environment, and it automatically then does the lookup of all of the test results. It's neat. So the packed broker key points. So the packs are published by the consumer, they're fetched by the provider, the results are stored in the matrix, and it's the matrix that supports fast, reliable, independent deployment because it keeps a record of every result of the tests. But not verbosely, it just keeps the success or failure. So what? So first, I guess, packed is free. This is always good. It's open source, which means... Good question. I will check. I think it's MIT, but I will need to check. It provides the DSL for most languages. It's got a DSL for C++. If you don't have a DSL, you can create your own adapter so that it will adapt the output of your test results into the packed format, so then you can comply in the packed architecture. Can I deploy? Gives you near instantaneous results about whether it's safe to deploy your component into the target environment. But quite frequently, the provider team needs to provide known test data start points. Otherwise, the consumer tests become very, very verbose. So, as if that wasn't enough, the pack team have come up with something that's halfway house between the mess that we were in before we had packed and contract testing, and the really quite neat situation that contract testing, consumer-driven contract testing leads us to. And they call it bidirectional contract testing, which is an absolutely rubbish name because I don't think it has anything, there's nothing bidirectional about it. I'll explain a little bit as we go. They're currently marketing it as available only in the paid-for version of Packed called PactFlow, which is a hosted service. Actually, all the tools that PactFlow use to implement bidirectional contract testing are open source and freely available. So you don't need to pay for a PactFlow license to use it, although it does simplify matters considerably. PactFlow, the bidirectional contract testing exists because it has been observed that trying to get organizations that already have many microservices to adopt consumer-driven contract testing is problematic, because you have to get the consumer team to write the DSL, then you have to have the provider team prepared to accept that packed file, run it, and have that communication. And there is some work to be done, especially when you need to set up the test data states. So even if the consumer is going to provide all the data for the test data state, the provider team still have to provide an interface that accepts that data and then sets up the database or whatever data structures they have using that test data. So there's quite a lot of initial overhead there. Also, it works, as I said, the consumer-driven contract testing model that we've described so far works really well within an organization, but less well with external, when the consumers and the providers are totally separate. So the external provider is maybe a commercial vendor, and we've got many paying consumers. So what they've tried to do is they've tried to say, well, look, we've got a halfway house. So a lot of these formal providers of services will be able to provide a specification. For instance, an open API specification. This used to be called Swagger specification, but now it's been adopted by a unilateral contract provider under one of the, I think it's Linux Foundation, and they're now on Open API specification version 3.1. And in that, it specifies an explicit contract to a level of detail that you don't get, that is not provided just with a web service endpoint. However, it doesn't go down to the level of detail that you would get when you actually look at the data that comes back from calling the provider. So the idea about bidirectional contract testing is that you compare the calls from your consumer against the service endpoints that are specified in the Open API specification. It's a static check. It never actually calls the provider. So it provides limited guarantees about correctness. However, it's super cheap to implement because the Open API spec, while not being a no-brainer, is not a complex artifact to create. And indeed, many organizations will be creating it already. There's a potential hope for it to get even slightly more useful in the future. The Open API spec has, for each of the verbs and return codes, it's got the ability for you to specify examples, which also include sample payloads. So although that's not currently utilized in bidirectional contract testing, it may be available in the future. So what? Packflow is a commercial tool. You will have to pay for it if you want to use it. It's provided by my former employer called SmartBear. It's a pretty good tool, actually. All of the functionality that it provides, you can host yourself for free. But of course, if you host it yourself, that's not free, is it? Because you'll have to host it, and you'll have to maintain it, and you'll have to update it. So that's what they're relying on. Bidirectional contract testing is not bidirectional; it's static, right? So I can't even imagine why they thought it was bidirectional. So it statically compares the pack file to the Open API specification, and other API specifications will be available in due course. Reduces the burden on the provider team, so you don't have to create setup data, you don't have to be able to have pack run actually against the provider component, but you get weaker guarantees from the process. Is there anything else to say there? No, I don't think so. So, takeaways. All interactions are governed by contracts. Contract testing ensures that both components have the same expectation. It actually verifies, your test doubles. The contract test should be written during development, so it's a developer technique. So, like so many things these days, it's got the testing word in it, contract testing, but it's not a QA job. It's part of the development process. When done well, it will increase agility and confidence. You are decoupled. You can be confident that you can promote things independently. These are big benefits if you get there. It will reduce your need for integration tests because you can now have confidence in your test doubles. Speeds up development. That's always a nice one to pitch to your boss. It won't speed you up to start with, right? There's a starting speed. But it's no substitute for communication, and it's a development activity. And it doesn't replace testing. So contract testing, development assurance, not quality assurance. You've got to test, right? You've got to test early. Like Kevlin was talking about, I don't know if you went to a session yesterday, you want to test early, you want to test frequently. But you're going to need to test throughout the process. Integration testing may be better than unit testing and may not be quite as good as end-to-end testing. However, again, J.B. Rainsberger did a wonderful talk a number of years ago called Integration Testing is a Scam. And I think there's a lot of truth in what he says. So it's expensive, but test doubles can't be trusted unless you compare their behavior to the actual component that they're replacing. So this is the marketing pitch for contract testing. We want to work faster, we want to work in smaller teams, we want to work independently, we want to be autonomous, but we need to, and we want to be decoupled, but we are at runtime coupled. That has to be accepted. And so at some point we need to make sure that when we actually sit down in an ecosystem where we're depending on other people's software running in a runtime, we have to be confident that our component will work with that component. And this process of contract testing using consumer-driven contracts, maybe using Pact to help you automate it, is cheap, it's easy, it's fast, and it is reliable. And my final question is, do you want a distributed monolith? That was a rhetorical question.